3.1, solving systems of equations by graphing or substitution. What we're going to be dealing with are systems. When we're talking about systems, we're talking about two or more equations graphed together. So you write the equations down. I have 8x plus 2y equals 9 and x equals 3. Also, I gave you graph paper. On the graph paper, I want you to make an xy axis. You're going to end up doing it to 4. Do the hamburger, the hot dog, so there's 4 in the front, 4 in the back. Now, we're going to graph both equations. Now, in order to graph these, they need to be in slope-intercept form. Is this one in slope-intercept form? No. I need to rearrange it. What needs to be moved first? Bless you. The x. I need to move the 8x. So I'm going to subtract the 8x over. So I have 2y equals negative 8x plus 9. Divide everything by 2. So I have y equals negative 4x plus 9 halves. Now I need to graph this one. How do I graph a 9 halves? It means 4.5. So it means go up 4.5. 1, 2, 3, 4 and a half. A common mistake, a lot of people think this is a slope and go over 9 or up 9 over 2. This just means you go up 4.5. From this point, what do? This is my slope, so I means down 4 to the right 1. Notice how I'm still in between, because down 1 is here, down 2 is there, down 3 is there, down 4 to the right 1. Now, it is very important that you do these problems with the ruler or something that has a straight edge. You have rulers on your desks, but you don't have to use a ruler. You can use your notebook, your calculator, something that's going to give you a straight line. Accuracy is going to play a huge part in this part. Take your ruler, draw a straight line as best as you can through the points. Notice how I am drawing the line through those points. Don't just play connect the dots. And I'm going to label y equals negative 4x plus 9 halves. This way I know that line means that equation. That's my first one. Now I'm going to do the second one. What type of line is x equals 3? It's not a horizontal. It is a vertical line that passes through 3. 1, 2, 3, straight line up and down. Got lost. Right here. That is x equals 3. What I care about on this problem is where they intersect. And they intersect right here at that point. That's why I need ruler, because accuracy is going to play a big part, because if you're off a little bit, your answer is going to be off a little bit. Where do they intersect at? What's my coordinates for this point? 1, 2, 3. 1, 2, 3, 4, negative 4.5. And that is your solution.
I didn't like that. Mine is a 7.
Okay, what you're seeing is my points weren't exactly, the line wasn't covering, right?
Yes.
Right, because my graph got moved. So it's actually down here, which 1, 2, 3, 4, 5, 6.5. So negative 6.5. Does that match you?
Yeah.
Right. Do you see how it's easy to make a mistake? Graphing, you have to be careful. Now, when you graph these, I am going to give you sort of a window of error. If you're like a point in between this point, I give it to you. It's from the heater. Here's this system. I have y equals 3x plus 1 and y equals negative x plus 5. So we're going to make a new xy axis. Do I have to rearrange either of these? No. Both of them are already y equals. Where do I start at for the first one? Up 1. Now what do I do? Up 3, 1, 2, 3, to the right 1. Draw my line. That looks pretty good. That one is y equals 3x plus 1. I label it. That way I know that's that one. To graph the second one. Now make sure you're using your ruler to draw the straight line. Just don't freehand it. Try to make it so it goes through your graph a good bit. That way you know you're going to have an intersection point. Yeah. Where do I start? I start up 5. 1, 2, 3, 4, 5. What do I do next? Go down 1 to the right 1. What do you notice? They just happen to be on this one, the same spot. What's my intersection point? Over 1, up 4. So my intersection is 1, 4. What this means is if I put in 1, 4 into this equation, that's a 4, that's a 1. What's a negative 1 plus 5? 4. It worked. Okay, that's a 4, that's a 1. What's 3 times 1? 3 plus 1 is 4. It works for both. It is the intersection point of both graphs. That is the only point that they share. If I had this point up here on this line, it does not work for this one. This is the only point, the intersection where they share. This is called independent variable or independent system. You actually get a solution. This one is called, it's independent, it's called consistent. Consistent, dependent, yes. Where I get the 1? Over 1, up 4. Right. I do my x, then it's y. It's always x comma y. It's consistent, independent. I got an answer. They intersect. No. Now, if they were like this, let me just erase all of this. No, I'm just erasing this. If it was like this, do they intersect? No. This is called inconsistent because they don't connect. It's inconsistent. Now, there's one other example. And it's hard to really show you the way it is. I'm going to do...
Wait, we're going to do it.
How about this? How about if they were like this? What do you notice about them? They're on top of one another. This is called consistent, but it's called consistent dependent. There's 3 different types of graphs. You have independent. They intersect, you're fine. That's consistent, independent. It's consistent dependent if they're just right on top of one another. They touch everywhere. It's inconsistent if they don't intersect at all. They're parallel to one another. How can I tell if things are parallel to one another? They have same slope. I want you to try to find the intersection point for this one. I have 2x plus 5y equals 14, and y equals 5. Now, rearranging, that's one of the most important things. If you rearrange incorrectly, these answers are going to be incorrect. I need to rearrange this top one. It's in standard form. It needs to be slope-intercept. What's the first thing that needs to be moved? Subtract the 2x. 5y equals negative 2x plus 14. What do I need to do? Divide everything by 5. So I have y equals negative 2/5 x plus 14/5. Now, graphing 14/5. What does 14/5 mean? 2.8. This means 2.8. So I go up 1, 2.8. It's almost 3. That last number does not tell me slope. It just tells me how far up. Now I need to go down 2 to the right 5. Down 1, down 2, 1, 2, 3, 4, 5. I have that. Draw my line. Try to be as correct as possible. This last problem. Right here. To graph y equals 5, what type of line is y equals 5? It is a horizontal. It is a horizontal that passes through 5. 1, 2, 3, 4, 5. It is right here. So it intersects right here about. So it intersects over here, my intersection point. They intersect up here. That's my first graph. That's my second graph. They intersect right here, which is 1, 2, 3, 4, maybe almost 5. So I'll say negative 5. 1, 2, 3, 4, 5. So negative 5, 5. Now, the one thing I want to show you, graphing, I don't like. Graphing by hand, you've seen, you have to be extremely careful. You have to rearrange correctly. You have to make sure when you graph, you put your points in the exact correct spot. If your line is off just a little bit, your answer is off a little bit. This one would have been, it depends on what I see. When I grade these, I look at the points that you have that you use to graph. And then I look at your intersection. I need to see all these things. Now, I'm going to show you a different way. I don't want to always have to graph by hand. I'm going to use a different method. This lesson was graphing and substitution. I'm going to show you substitution. What does it mean to substitute? Put something in to something else, right? If you notice right off the bat, y equals 5. So I'm going to substitute this y equals 5 into this problem. So I have 2x plus 5 times 5 equals 14. I substituted, I exchanged the y for 5. What's 5 times 5? 25 equals 14. Now I need to subtract 25. 2x equals negative 11. Divide by 2. X is negative 11 halves. Negative 11 halves is negative 5.5. What did we say our answer was there? Negative 5. We're off a little bit. This is the exact answer. Now, I need to find my y value. What's my y value? 5. It just tells me. The solution is negative 11 halves, comma 5. Negative 5.5, comma 5. That is the exact answer by substitution.
What about that person?
What do you mean? I could have substituted this negative 11 halves up here and resolved. I would have still got 5 as an answer. Let me show you in a different problem. I don't want to graph this one because I got to do a lot of rearranging. I have decimals and whatever. I'm going to use the substitution method. To use the substitution method, you have to have x equals or y equals a problem. I can rearrange any problem to get that. But on this problem, you already noticed you have x equals something. X equals this, right? All I'm going to do is substitute this into this one. Sort of like fog and goth. So I substitute, replace x with this. Negative 3 times 0.5y plus 6 plus 2y equals 31. Now I'm going to distribute. What's negative 3 times 0.5x, or 0.5y? Negative 1.5y. Please make sure that your decimal points are pronounced, that you can tell that's a decimal point. Because a lot of the times people make their decimal points really light. And if you look real quick, what does that look like? Negative 15. You want to make sure you know that's a decimal point. What's a negative 3 times a 6? Negative 18 plus 2y equals 31. That negative 3 does not go to the 2y or the 31. If I was giving this table here $5, does this table get $5? No, I only said these two are getting $5. This person doesn't get anything. This person doesn't get anything. That's why I put the parentheses there so you know to distribute. Now I try to combine my like terms, which happens to be the negative 1.5 and the 2. 0.5. So I have 0.5y minus 18 equals 31. Add 18. If I add 18 over 0.5y. Notice I'm writing 0.5. That way I know it's a decimal point. Is this right here? Equals 49. When I add the 18, I get 49. Now what do I have to do? Divide by 0.5. But I know that 0.5 means a half. Now to get rid of a half, I multiply by the reciprocal, which is 2. 49 times 2 is 98. You can use a calculator, you're allowed. So I know y is 98. You would have never got this by graphing by hand. This would have been way off your graph most likely. If you would have counted by ones, you would have had 5 sheets of paper high. Now I need to find x. There's 3 ways I can do, or 2 ways I can do this. I can substitute it back into this one or this one. Which one do you want to substitute into, the top or the bottom? Why the bottom? It's shorter. It's already x equals. So x equals 0.5 times 98 plus 6. What's half of 98? 49 plus 6. 55. So my x is 55. My final solution, 55, 98. This is the work I'd like to see. You need to make sure you're being neat when you solve these problems. It's very easy to mess up. Don't try to shove all this work into one line on your piece of paper. Questions? Here's this method, or this problem. I have 3x plus y equals 5. 2x minus y equals 10. Just write it down first. Now, I'm not going to graph this. I'm going to show you substitution. The thing about this, I can solve this problem a total of, I think, 8 different ways. Everyone can solve it a different way. There's 8 ways, but one way is the most efficient. I can solve for x here if I wanted to, but then I got to move this over, then I got to divide by 3. Too much work. If I solve for this y, I just move the 3x over. Easy. Just to show you, this one, to solve for x, I got to move the y over, then divide by 2. If I solve for this one, I got to move the 2x and then change the sign of everything. This one's the most efficient one to solve for. So I need to move the 3x over. So I have y equals negative 3x plus 5.
Okay.
All I did was rearrange the top one. Once I rearrange that, what do?
Solve.
I solve. How do I solve?
Right? Yeah, minus 5.
No, I already have y equals. I substitute this into the bottom equation for y. Since y equals negative 3x plus 5, I put it in there. So 2x minus, now I put it in parentheses, negative 3x plus 5 equals 10. Y means this. I distribute 2x plus 3x, because the negative times the negative, but then I have minus 5. Why is it a minus 5? Because the negative times the positive gets me a negative. Combine these two, what do I get? 5x. Now what do I have to do? Add 5 over. 5x equals 15. Divide by 5 and I get 3. I've got 1/2 of the problem solved. Now I've got to find out what y is. I can take this x and put it into any of these problems. Which one do you want to put it into? I'm going to put it into the top one over here. The reason why. Y equals negative 3 times 3 plus 5. Negative 3 times 3 is negative 9, plus 5 is negative 4. So my solution is 3, negative 4. Questions?